I greet you all in the mighty name of Jesus Christ. This is OPERO Stephen, welcoming you to yet another edition of OS e-learning platform. My brothers and sisters, I hope you're doing well. But before we continue, let's first pray. Jesus in heaven, we thank you for loving us. We thank you for sacrificing yourself for us. As a community of OS e-learning platform, we call upon your guidance in this next discussion. We can't do anything without you, but we can do everything with you, Father. We need you to guide us. Whoever is to tap on this today, may his or her life change forever, academically, spiritually, financially. Jesus, we thank you. Our brothers and sisters in the section of Muslims, we welcome you all together, and we believe in the mighty name of Allah that whatever we pray for, we do receive. Thank you all. Thank you for all your effort. Thank you for the contribution. Thank you for the support. Thank you so much. Let's get into today's discussion. So today we still have mathematics 4561, and basically we are going to have a discussion on a simple topic, equation of straight line, under the theme pattern and algebra. So the topic is equation of a straight line under the theme algebra. Before I start with any item, allow me to talk about something as far as a straight line or equation of a straight line is. Now, for us to come up with a straight line, we must have at least 2 points or 2 coordinates. And these 2 coordinates, once we plot them, for example, if I have a coordinate 1, 2, then another coordinate, if I have another coordinate 2, maybe 0, and these are 2 coordinates. So if I have my Cartesian plane, with the x-axis and y-axis. Remember, this plane should contain all positive and negative, and stating that this is 1, this is 2, this is 3, this is 1, this is 2, 3, etc. I'll have negatives also, just that I don't have the negative in my coordinate, negative 1. So if I'm to plot, remember here is a 0, I have a 0. So if I'm to plot these coordinates, say A and then B. So plotting these 2 coordinates, A will be, we start with the x-axis, this is for the x-axis and this is for the y, for that A. Then still x-axis, y. So if I'm to plot these coordinates, for A I will have x is 1 when y is 2. So I will plot it somewhere here. Then if I'm to plot b, so that will be point A. Then for b is 2, 0. X-axis is 2, then y-axis is 0. So this is where we have 2 as x-axis, then the y-axis is 0. So that point there, 0. So on plotting this, I have this coordinate also plotted. So if I'm to join these 2 points, I come up with what we call a line. Now, if we have these 2 points or coordinates plotted, we come up with what we call a straight line. And then we can ultimately get its equation using the standard form y is equal to mx plus what? Plus an intercept c. This intercept can be the y-intercept or the x-intercept, depending on where it is cutting, where the line is cutting the axis, or which axis is meeting the line. So if you check keenly here, you can see that this line at B is cutting the the x-axis, and then meaning at that point always y is 0. So this can be the x-intercept when y is equal to 0, or this very intercept can be the y-intercept when x is instead equal to 0. So at a point where it cuts the y-axis, at that point our x is always 0. Then at a point where the line cuts the x-axis, at that point the value of y is always 0. So that should be noted. Now, for us to come up with the equation of a line, first and foremost, I need to get these 2 points. If I'm given, then well and good. So given the 2 points, I can now get the equation of a straight line. So the steps I need to follow are I need to get the gradient or the slope, the incline, the slope. So I need to get to the slope, also called the gradient with capital O small m. So the gradient is defined by change in the y-axis over change in the x-axis. Now we look at the values taken as the coordinates for this particular line or any other line. Like for this we have A and B. If I want to get the gradient there, I will say m is equal to, let me call this one y, x1, x2, x1, xy2, y1, x1, y1 for the first coordinate, y1, then x2, y2. So this will give us y2, change means minus, y1 over x2 minus x1. So when I substitute to get the gradient or the slope of the line, I will get my 0 as x2, then minus my 2 over my 2, which is the x2, minus 1. So this matches with that. Then for the x, then for the y, this minus that. So this will ultimately give me something like negative 2 over 2, and the answer is a negative 1. So which is vividly seen that the gradient here, the gradient shows that there is an inverse proportionality. In other words, as the values of a certain variable, for this case we have y, as they increase, the values of a certain variable called x reduce. So they are inversely proportional. So that's why I have a negative. So just in case you are requested to calculate the slope and they want you to explain the significance, for a negative slope, an increase in one variable leads to a decrease in the other variable. Negative slope, negative 20, negative 3. So the significance is that. Then, if I want now to get to the equation of the straight line now, for this case, the straight line, what I'm going to do is very simple. You don't need to worry. I will pick any point along on that very line. I will pick any point on that very line. Now that I have the gradient, I pick any point. So for this case, I can decide to pick point A. So point A, I have my x as 1, and then my y as 2. Remember, my gradient is already negative 1. So I have to substitute in the standard equation of a line in this equation, and we get the intercept y being equal to mx plus c. So I have to substitute my y is 2 is equal to my gradient is negative 1, x, my x is 1, allow me put in bracket just to mean multiplication, plus my intercept that I'm calculating. So here I'll remain with the negative 1. When that negative 1 crosses an equal sign, becomes a positive. So my intercept here will be positive 3. Now I need to get to the equation of a straight line. The target here is you just need to look for the c, which is the intercept, and also the gradient. After getting that, those are the only values that we are going to substitute in this equation for gradient and in this equation for intercept. Therefore, the equation of a line will be y is equal to m is negative 1. The x, I maintain that x. Then the intercept will be 3. And that is majorly the x, the y-intercept. What they are meaning here is that the curve, or the line, will cut the y-intercept at point y is equal to 3. Actually, if you prolong this line, you get to realize that it is to cut at this point. So that's what they are meaning. So therefore, y will be equal to negative x plus 3 plus 3, and this is the equation of that particular line. So for us to get the equation of the line, you need to first get the gradient. After getting the gradient, pick any point on that line. If they are given, pick any, as long as they are lying on that very line. So you get the value of x and y, substitute in the standard equation, solve for the intercept, and that intercept is the y-intercept. Then you substitute only the intercept and the gradient in the previous standard equation of the line. That will give us the equation of the line, particularly in slope or gradient are very, very important here. You just look at the change. change in the values. The negative slope means increase in one leads to a decrease in the other. On the other hand as well, a positive slope means a direct proportionality. In other words, when one increases, the other one also increases. For example, if you increase as a scholar the rate at which you do research, discuss with your friends, consult, do discussions, even your performance in terms of improvement increases, so it is a directly proportional thing. And on the other hand, if you joke around, you don't read, you take things for granted, things also take you for granted, so it's a direct proportionality. Are we together? So how about that case of direct proportionality before we go to how to get the length of the line? Direct proportionality. For example, I have my Cartesian grid here. I will still consider the positive ones, don't worry. X and Y up. Then I have my points A as maybe 1, 2. Then B as 2, 4, something like that. Then we need to plot, this is 1, this is 2, sorry, the scale must be uniform, 3, this is 1, this is 2, this is 3, and then 4. If I have such a scale, and I need to plot my coordinates, A is 1, we start with the x-axis please, this is x, this is y, x, y, so we start with the x-axis. On point A we have 1 and 2, somewhere there, that is point A. Then point B is 2 and 4, 2 and 4 somewhere here. Somewhere there, that is a B. So if I join this line, be patient please, if I join this line, I get a line. We agreed that any 2 points plotted can come up with a line, whether they are negatives, positive. Once you join those 2 points, come up with a line. Then any other point must be within that line formed. So I need to get the gradient. We agreed changing the coordinates on the vertical axis for that, and then changing y, x. So here, these are the values of y, and these are the values of x. So let me just get the change very fast. I can take this as my x2, y2, then y1, y2. So I have to subtract 4 minus 2 over 2 minus 1. So 4 minus 2, we start with the y, or the vertical axis, then over 2 minus 1. If you're vividly observant, you can see that we are getting a positive answer here, which is 2 over 2, and the answer is 1, positive. It's a positive 1. This one shows that the significance or the implication of this positive gradient means that as the variable on the horizontal axis increases, I do not want to majorly talk about x-axis, y-axis, because these variables can change. We can be talking about other things and after you relating it to a certain variable, then you plot. So the variable plotted on the horizontal axis, as it increases, the variable plotted on the y-axis also increases. No matter whether it starts from the origin, whether it is starting from any other point, the line can start from there, it can start from the origin, it can start from 3, anywhere, as long as it increases either sides. Then the opposite is inverse proportion. It can start from there, it can be on the negative, it can anywhere. So basically the significance of the gradient should be observed very well. Now if you are to get the equation as well, still that is a walkover equation. We agreed y is equal to mx plus c. Now that we have our any point, taking any point, I can take b is 2, 4. Now if b is 2, 4, I have to substitute. This is my y and this is my x. So I will substitute 4 is the y, is equal to the gradient is positive 1. The gradient is here. Positive 1, we got it, so I will put here positive 1. Then my x is 2. I'm looking for the intercept. So if you work out this, we get the intercept as 2. So if you're very accurate, you get this even by graphical analysis. So the intercept is 2. Our target is to get the intercept only and the gradient for us to get the equation of the line. So we come back to our equation. Y is equal to mx. So where m is, I put 1. Then I maintain my x. Then the gradient is, the intercept is 2. So finally, y will be equal to x plus 2. So basically that will be what? The equation of the line for the positive gradient. Should be careful with that, and in case you get a negative gradient, please substitute it with it is negative. So what else do we need to know about lines? We need also to know how to get the midpoint of a line, the coordinates of the midpoint. And then finally we shall also get to know the length of the line. How do we get the length of the line? So basically the two that are remaining we need to highlight, then we start the scenarios, real life application of what? Of lines. So if I have my coordinate, for example, this is a, let me just have a Cartesian plane so that we can come up with something very clear. Be patient. Or if you have a graph paper, please do this on a graph paper. We'll come up with accurate values, accurate coordinates. So I will still maintain this as my x. I will still maintain this as my y, of course, as usual. Then this will be my 1, 2, 3, 4. So this will be 1, 2, 3, 4. Of course, don't forget the negative. This is a Cartesian plane. Since I'm interested in positive values, just for simplicity, 1, 2, this is 3. I just want to come up with another line. Then we determine the midpoint, coordinate of the midpoint. Taking a situation where maybe I have a line passing from here, like that. That's my line. Then I have these coordinates here. Coordinate there is 0. The coordinate there is 0, 1. Then I try to get another coordinate somewhere here. Oh God, coordinate somewhere there. I get 2 on the x-axis, 2, 2, 2. Then I get the final coordinate maybe somewhere there, that is ABC, and which is 4, 4, 4. Then I task myself to get the coordinate of the midpoint. For example, from A to maybe B. Taking this one as V maybe. So what is the coordinate of the midpoint of the line if I'm starting from A up to B? And the coordinates are 0, 1. Then I have 4, 4. So if I want the coordinates of the midpoint is somewhere here, meaning I'm going to take half of this, half the distance. I'm going to travel half the distance horizontally and vertically. Even on B, I will travel horizontally half, vertically half. So the distance, the coordinates will be now, coordinate will be, I will travel half, so I will get x1 plus x2 over 2. So I will take the average distance, average value. Then for the other y-axis, y1 plus y2 over 2. Still I will take the average because I need half of it. So my x is this and also this. My y is this 1 and this 4. So I just need to substitute. So if I get x as 0 plus 4, that will be 4 over 2, comma. Then my y will be 1 plus 4. 1 plus 4 is 5. 1 plus 4 is 5. Then 5 over 2, that will be something like 5 over 2, that will be something like 2.5. So this will be 5 over 2. And this will give us the midpoint, and the midpoint will be 2, and 2.5. So that will be the coordinate of the midpoint. At some point here we shall get 2 on the x-axis, then 2.5 will be somewhere there. So you can ideally see that from here up to there, surely a half of it is here. I'm not using a graph paper, but you can also see. Not actually at V, but some point after V. So that's how we can get the coordinates of the midpoint. Just in case a scenario wants you to identify the midpoint of two coordinates, that's how you shall do it. Take x1 plus x2 over 2, comma, because coordinate must be written in pair. So then y1 plus y2 over 2 for the midpoint. Lastly, let me talk about the length of a straight line. How do we measure the length of a straight? How do we determine it? Well, you can use a ruler to measure, tape measure, which is okay. Then how do we do that? How do we measure the length? How do we determine the length of the straight line if you have these two coordinates now? If you have the two coordinates, how do we determine that as we prepare to get into a serious scenario? Then I will leave you with sample items and we'll call this a day. As we call this a day. So I'm taking a situation where I have this straight line, and maybe you can get me coordinates there, maybe 2 and 3. Then I have maybe 1 and 3, maybe and 2, something like that. You just need to pick small values for convenience. So distance, also called the length, will be obtained from the square root of the difference in x2 minus x1, everything squared. So we cover this mostly in locus, into y2 minus y1 squared. Now why do we start with y2 x2? It is because I'm measuring the distance from B to A, and if I'm to measure distance taking a situation whereby the coordinates are on this side, I'm taking them as x1, x2, then this side at A, x1, y1. However, if I'm to measure distance from A to B, then that would be something else. So I'm measuring the distance from B to A. So I will substitute the values. This one's here will be for, I start with B as x2. So I will have 1 minus 2. That is a negative. Remember, I'm to square it. So that will be squared, plus y2 is still 2. I read coordinates from B are the ones I start with, minus 3. Then I square everything. So get to realize this is 1 plus 1, so the whole answer will be square root of, this is 1 squared, 1 negative, negative 1 squared positive. So the whole thing will be 2 units. If the units are kilometers, then it will be 2 kilometers. If they are centimeters, 2 centimeters. And if they are not given, then they become units. So basically, we should take care of that while determining the distance or length. Well, now prepare to get into one sample scenario that will give us a way forward to try your items, and every time you get a chance to try these items, please send for assessment. Send them for assessment. So here is a simple scenario. A small town in eastern Uganda is planning a new bus route to connect the town center to the nearby industrial park. The town council has a limited budget of Uganda shillings 1.5 billion for the infrastructure. To maximize efficiency and minimize cost, they want to design the most economical bus route. The town has collected data on the locations of key landmarks, that is the town center at 00 origin, industrial park 64, the park entrance 32, and then the school 11, and has presented to you to help them confirm if the bus route will pass through all the locations before they start the implementation, as they intend to set up a straight bus route from the town center. Task: using the knowledge of mathematics, help the town clear their query. So they want to confirm whether it is really going to be possible for the road to pass through all these locations. B, if the construction company charges 100 million per kilometer constructed. Confirm if the budget will fully support the program. So I will first make some adjustment here. This is not actually 1, because in the solution I have 1.5 million, 150 M, correct that one. So they charge 150 M per kilometer constructed. So they want us to determine what? Whether the budget will work or will fully support the program. Part C, if the area member of parliament intends to establish a public borehole midway the school and the industrial park, determine the location of the borehole. So basically what we've been discussing, all is actually highlighted here. We need to get the equation of a straight line and confirm whether the straight line is the same throughout. We need also to confirm whether the money will be enough, meaning we need to know the distance of the length of that straight line from the origin up to the industrial park. We need also to know the midpoint, that is from school to the industrial park, midpoint. And then we get the position where the borehole will be located. Response for part A. Now that we have the information for the town, that's the origin industrial park 6.4, then the park entrance 3.2, school 1.1, we can now get the equation of the route from the town to the industrial park. Since we are moving from initial point to the final position, let's get the equation now. Gradient, we agreed that one. Change, we substitute. My y2 is 4, y1 is 0, x2 is 6, x1 is 0, then I get 2 over 3 as the gradient, which is a positive, meaning it is directly proportional. You get that. So if I pick any point on these two locations, I can take 6, 4, another person can also take 0, 0, we shall get the same answer. So taking 6, 4, I get industrial park. Equation of the straight line from the town center to the industrial park as y is equal to mx plus c. Substituting, remember we agreed from this coordinate you're taking, you have to pick x and y, and I'm solving for c. Ideally everything crosses and I get c as 0. The equation of the bus route, therefore from town center to the industrial park, will be given as y is equal to that, and that is 3y is equal to 2x. You might be wondering how this is coming to that caliber. So if I want to move this 3, I have to multiply it through both sides by 3, times 3 here, times 3 there, and also times 3 here. So that's why I'm having that. Then from here, if I cross 3 by 3, 1, by 3, 2. So if I multiply this 2 times 2, I get 4. Then taking the 4 the other side becomes a minus. So here I remain with the c. C will be equal to 4 minus 4, and that is a 0. So that is done. So we get to realize that the equation of the straight line from the town to the industrial park is actually that one. It's actually 3y is equal to 2x, or y is equal to 2 over 3x plus 0. Equation of the route from the park entrance to the industrial park. Because for you to get into the industrial park, then you must have the entries. So what is there at the entry? Do we get the same straight line? Let's check. So the slope, as usual, we know that. Get the difference in y, difference in x. Ideally, we are getting the same gradient. And the mathematician who is present today is seeing something. Is seeing that the gradient here is the same as the gradient here, from the center to the industrial park. Now before we enter the industrial park, we need to know the entrance, and of course unless otherwise, so the entrance must be straight to the industrial park. So let's get to see the equation of the straight line now, if that is the case. So we are taking any point from this park entrance and industrial park. So I'm taking this time round the case for Parker entries. Not to say now, teacher, you took Parker entries at first, here again you are taking Parker. What are you? So I'm going to take Parker entries. Not to harden anyone's life here, please. So still the standard equation, y is equal to mx plus c. I'm substituting for y as 2, then for x as 3. Remember, the intercept is 2 over 3. Substituting, I'm still getting 0. So the equation of this route from the park to the industrial park, entrance park to the industrial park, is still giving us the same equation, which is 3y, because ideally, my brothers and sisters, you can also witness this, that a 3 is crossing with a 3, and then here will remain with a 1, and then 1 times 2, that is a 2, so the whole thing goes to a 2, so the 2 will cross, and when it crosses an equal sign becomes a negative, so the 2 minus 2 becomes a 0. So that's why I'm getting my y-intercept as a 0. So to get into the equation, I still get the same equation as per the previous one. Something is happening here. So we can vividly see that the park, the industrial park, so the park entrance, industrial park, and also the town center are actually lying on the same line. Meaning, if you are to sample now the town, or even if you want to sample the town center and the industrial park, if you are to sample these two coordinates, you will get the same gradient, because now y2 will be equal to 2 minus 0, then I'm looking at the gradient, then 3 minus still 0. So this will be 2 over 3. And then now the 2 over 3 is the gradient. Remember here, if you have the same gradient, now that I'm taking any point, you can even decide to take 0. I get still the intercept as 0, then my final equation will be of this caliber. So we can vividly see that the town council, the industrial park, but before the industrial park, even the park entrance and the industrial park are all lying on the same line, because they give us the same equation of the line, the same line, and the same gradient or slope. Okay, so let's go to the next, but before that, let's first erase this. Okay, something is happening, and you can vividly see that. Move to the next response. Equation of the route from the industrial park then to the school. So the 2 must be here, please. Okay, what is the situation here for, or what is happening with this line from industrial park, or the route from industrial park to the school? Now we need to get the gradient as usual. Okay, y2, y1, x, taking my school as the second coordinate and this as the first coordinate. No matter the arrangement, they give you the same response. Or we are getting here gradient, which is 3 over 4. Something is about to happen. We get to realize that the gradient is not the same. So meaning, if I try to twist this in terms of the equation now, taking any point 1, 1, I'm getting an equation. Of course, the c will be negative 2 over 4 and ultimately negative 1 over 2. Then my equation of the straight line, or equation of the bus route from the industrial park to the school, is that. Check here, check here, check here. So this equation is totally different from what we've been having. So at some point, we are getting to realize that the school is out of the bracket. The road might not pass through the school. So we can conclusively see that if you compare the equation of the bus route from town center to industrial park, it is that very 3y is equal to 2x. And also from the park entrance to the industrial park, I'm getting 3y is equal to 2x. Also, when we sampled from the town center to the industrial park entrance or the park entrance, you're getting the same equation. But now when we connect any of these to the school, we get actually the different equation. So you can also test at your free time. Test industrial park with the, okay, we have done industrial park with the school. Now test park entrance with the school and you confirm. So from this we can ideally see that the school is giving us a different equation of line, meaning it is out of, or it's not on that map. So the road or the bus route will not pass through the location of the school. Therefore, the bus route won't pass through all the locations. Since the location of the school gives different equation of line, as the bus route won't pass through the school's location. So whatever they are doing, they should keep in mind that the school is out of context. And I wanted us to prove this by plotting just roughly here. We see whether it is really correct, whether the school surely will be, or the school will not be on the map of that bus route. So having my Cartesian equation here, Cartesian plane, I just want to plot. Good enough, they are all positives. I have 1, I have 2, I have 3. Oh, I have even x as 6. I have 4. Use a graph paper and prove me wrong, please. I have 6 here. This is my 6. So this is my x-axis. Then for y-axis, the biggest value is what? Is it 4? This is 1. This is 2. This is 3. This is 4. So let's plot now. We have the school as 1, 1. The park entrance as 6, 6, 4. Sorry, the industrial park 6, 4. The park entrance, oh god, the center, town center is 0, 0, 0. Let's first plot this as we confirm the other. So we shall have the town origin at this point, the origin at that point. Then the school will be at 1, 1, somewhere there. Then 6, 4, that is for industrial park, 6, 4. 6, 4 somewhere here. 6, 4. Then 32, 32 for the entrance park or park entries. So since I'm moving from the origin, you can see that my line goes through these 3 points. That is the town, the park entrance, and the industrial park. But it's leaving out the school. The school is out of that bus route. So basically, if you are plotting as well, you will get as well get the same response. Though here basically I wanted us to practice much of calculations to see that we get into this in good faith. Alright, now let's get into the next episode or next slide. B. So they are charging 150 million per kilometer constructed. They want to confirm whether the money money in the budget will satisfy the program. And remember, they are intending to establish a straight bus route from town to industrial park. And you've seen it when you plot it on a graph paper. So we need to get the distance. That's from 0 to industrial park, and that one is a walkover now. Just substitute in our equation, and then that will give us square root of 52 kilometers. Of course, larger distances, we shall take case of kilometers, however much is not on. Okay, actually it is even given. They are charging 150 millions per kilometer, so it is in kilometers. Now here 150 millions for 1 kilometer. How about 52 kilometers will go to that money? About 1,801,365,382.639. So from the budget we realize that the money planned is 1,005,000,000. Then we can deduct the money meant for the project, and then we can see that we are actually, the town council is left with some good money. About, if we create these commas here, this is some reasonable money that we can use and set up something, unless it goes to a different pocket. What is this? This is 4 million. Oh, beyond even 418 million, 334,617.361. So if this money goes to another venture, we can still benefit from it as the public. So therefore, the money stipulated to establish the infrastructure will be enough. You can vividly see we shall be left with a good amount of money that will be spent on other activities within the town council. So we are determining now the location of the public borehole. I think the 418 million will be enough. Sure, constructing a public borehole. Given that we have the location, Midway School, I think if you want to provide a school with the borehole and also the industrial park for other industrial use. So they are estimating the midway or the midpoint of these two locations such that they can all benefit from this water source. Midpoint, we agreed, that's how we obtain it. Substituting the variables, we actually get 3.5 to 2.5. If you are using a graph paper, you must get the same response. So therefore, the location of the borehole is 3.5, 2.5. Basically, that is what I had to share with you today. Now that you've learned something from this presentation, why not expose your understanding? Why not explore your heights in the next items that are for you to try?